Hello everyone. Now I'm going to present my research entitled Mathematics Work Examples with Tracing Gesture Makes Learning Last. This is the outline of my presentation. I will start with introduction, followed by objective of study, hypothesis, method, data analysis, results, discussion, conclusion, and references. Within the framework of cognitive load theory, numerous studies have demonstrated that the potential of work examples as an effective instructional design for the novice learners across a range of domains. These studies highlighted the significance of work examples in reducing cognitive load to encourage the construction of better problem-solving schema. A meta-analysis published in 2023 indicated that the type of work examples with all correct solution steps are beneficial for learning. Drawing on evolutionary upgrade of cognitive load theory, previous studies suggested that the learning of biologically secondary knowledge, such as mathematics problem solving, may be further enhanced with the use of biologically primary knowledge such as hand gestures. This suggestion is in line with embodied cognition perspectives, which argue that the use of bodily resources such as hand gestures to offload cognitive work onto environment is assumed might reduce cognitive load for better schema construction. The present study focused on the effect of specific type of hand gesture, namely tracing gesture, which is a simulation of writing or drawing by using finger. Recently, there were experimental studies suggested that the use of tracing gesture could reduce cognitive load to generate more cognitive resources available for better schema construction, will further enhance the learning from work examples. In addition, the existing studies also had discussed that hand gestures has significant effect to reduce cognitive load in embodied way of representing ideas, thereby freeing up more cognitive resources for encoding new information in more lasting format. Thus, the learners who produce gesture while learning helps in the retention of knowledge and consolidate the learning. Since the robustness of tracing gesture effect in work example-based learning are still understudied, thus the objective of this study is to further examine the findings of previous research on the facilitation effect of the tracing gesture in the work example-based learning over time. In this study, it was hypothesized that at the delayed post-test, the learning outcomes of tracing group better than non-tracing group, whereby the better learning outcome was indicated by more number of correct answers, shorter total solution time, and lower ratings of test difficulty. There were 60 participants in this study with the mean age 12.37 years old. They are novices to the topic of angle relationships involving parallel lines. The participants were randomly and evenly assigned to one of the conditions, either tracing using index finger or non-tracing group. The experiment consisted of 3 phases: initial instruction phase, acquisition phase, and delayed test phase. Each participant was asked to complete each phase individually. For initial instruction phase, all the participants in both conditions were given 5 minutes to study a 5 pages instructional material. For acquisition phase, all the participants were given 2 work examples with 2 minutes to study each of them. Each work example was paired with similar practice questions. The participants in tracing condition were required to trace out the specified elements of the diagram by using their index finger of their writing hand, as stated in the instruction of every solution step. For the non-tracing group, the participants were required to read and understand the solution steps in the work examples with their hands placed on their laps. Approximately 4 weeks later, the participants were asked to solve 6 problems in a delayed test to measure their learning outcomes. The first 2 problems were similar questions to the work examples, which could be solved in 2-step solution using the correct angle relationships. The next 4 problems were considered as transfer questions, which required 3-step solution. After the participants solved each problem, they were asked to rate the difficulty of the problem immediately by using 5-point illustrated subjective rating scale, ranging from 1 being very easy to 5 being very difficult. This is the work example for the tracing group. The independent variable in this study is gesturing condition, which is tracing and non-tracing. The dependent variables are the number of correct answers, total solution time, and ratings of test difficulty. A series of t-tests was conducted to find out the significance difference between tracing and non-tracing. The result of the data analysis reported the test of significance at alpha level of 0.05 together with the estimates of standardized mean difference effect size. The means and standard deviation for the dependent variables under analysis are shown in this table. For similar questions and transfer questions, there were significant differences for both conditions in the number of correct answers, total solution time, and test difficulty. The effect size for correct answer and total solution time are moderate, while the effect size for rating of test item difficulty is large. The results show that tracing group significantly outperformed the non-tracing group at the 4 weeks interval delayed post-test. The tracing participants have demonstrated more correct answers and shorter solution time and reported lower levels in the ratings of test item difficulty compared to the non-tracing condition. The findings suggested that the incorporation of tracing gesture in the work example learning will help to reduce working memory load by offloading cognitive work onto physical environment to increase the available cognitive resources for schema construction. These findings are consistent with the previous research that demonstrated the use of gesture might help the learners to retain the knowledge gained and consolidate the learning. However, the present findings were in contrast with previous study that positive tracing effect was not found at the delayed post-test. The possible explanation might be due to the longer time interval of delayed post-test, which was conducted 3 to 4 months after the instruction phase. Besides, the participants recruited in their study were low-ability students. Thus, further experimental works are clearly required to clarify these mixed findings in terms of the time interval of delayed tests and also the individual's cognitive dispositions. As conclusion, The present study has demonstrated that the use of tracing gesture has provided physical or sensory motor experience in encoding visual spatial information, further enhanced the work example-based instruction. It was found that tracing gesture has significant effect in the retention of knowledge and promote lasting mathematical learning. These are the references used in this study. That's all from me. Thank you for your attention. Bye bye.